this particular one, it's going to help us reinforce our graphing skills, which we use obviously all throughout the school year. Secondly, we're talking about PSAT coming up. So I've got between now and the next couple of weeks, the assignments I've got built for us. It's going to keep reinforcing everything that we're doing. So it's not like it's a one and done thing. All the assignments keep having a little bit of practice. Yesterday as well, the quadratic formula is going to be on tonight's lesson. It's not going to be like one and we're done with it. And then obviously rolling it out for 2 next year as well. Okay, so let's jump right here into it. We're going to talk about inequalities, and as you can see, as always here, there's a little bit there on this inequality work today. We're going to talk about merging your inequalities with graphing a line. So let's go, let's go. We're not going to do every example up here with things because well, you guys are usually pretty with it, so let's go, okay? All right, let's go. Let's see what you guys remember if you've done this before or not. We get ourselves an inequality up here, okay? Not just any old type of inequality, it's what we call linear inequality. You guys have graphed lines since 6th grade. Now the question is, have you graphed a linear inequality? I'm hoping you have. As I've seen some heads nod, that's good. Okay, so what we have here is a linear inequality. We're going to graph those in just a second, but I already got this one graphed out for you. This is our linear inequality that is graphed out right here. Okay, we graph it out the exact same way to start off with. We graphed out our y-intercept. We graphed out our slope, up 1, right 2, up 1, right 2, blah, blah, blah. Now here's the catch. It's an inequality. We know inequality is going back to way back when. Either has an open dot or a closed dot, right? Open dot or closed dots. But we don't really have necessarily an open dot or closed dot here. We have either a solid line or a dashed line. So with solid lines or dashed lines, it depends on what's going on with that inequality. This inequality that's here, that's obviously our less than symbol, right? There's no underline underneath it. There's no or equal to that's there. So that goes back to our what? Open dot, okay? When we graph this line, this boundary line we call it, our open dot correlates to what we say is a dashed line. They are one and the same, okay? So what we do is we take our ID and make a dashed boundary line. That's what they did for us. And then as we do inequalities, we got to shade. Typically, you've grown up with shading left or right. Here, we need to shade either above or below the boundary line. Don't overthink things. Why do we shade below the boundary line? Because what's the inequality symbol? Less than. Okay, so they shaded below. And what does that mean? Anything that is below that boundary line is part of your solution. Being in the shaded region, that is our solution set. That's where you want to be. Okay, that's it. So what we have here is, if you have not done so yet, which of those following points are part of the solution set? Are you in the shaded zone, yes or no? Okay. So real quick, yes, no, 0, 0. No. 0, 0 is right here. What's the next one? 2, negative 4. Clearly 2, negative 4 is 0, negative 5. Clearly it is right as well. 0, negative 4. I heard a yes, I heard a no. Now it's on the boundary line. It depends on what that boundary line is. If it's solid or dashed. Dashed means it's open. That's an open dot. And what do open dots imply? Open dots are part of the solution, not. It is not. So dash means it is not. It is not part of the solution. Yes, it's on it, but you got to think about, what does a dash mean? Dash means open, it's not. I always tell my students, it's like you hear about this party going on. You hear about it, but you don't get the invite. Okay? That's like what an open dot is. You hear about it, you're close to getting that invite, but you never get the invite. You know, just like Caden all the time. Okay? Now, eventually, maybe every once in a while, Caden gets that invite. And as soon as he gets that invite, he gets inside that house, all right, and he's part of that party. That's a closed dot. That's a solid line. But if he doesn't get that invite, he just keeps hearing about it. Okay, he's not inside that house. All right, he's close to getting that invite. He's just staring outside the house from the window, being a creeper staring in. Okay, sounds about right, guys? All right. So with that, That's the difference there. So you're close to being a solution, just not quite. You're close to being at the party, just not quite. Right, Katie? Okay. Okay. So what did we say? 0, -4 is not. What about -2, -5? So that's not. And then lastly, 20. It's way off there, comma 0. But what's going to happen here? It continues on, right? And that's clearly going to be in the solution zone, isn't it? Okay. So now, based on all that, okay, what will we need to change then for that 0, -4 to be a solution? What would need to happen for 0, -4 to become a solution? We would need to make that a less than or equal to. The inequality would need to be correct, less than or equal to. As soon as we put that equal to, you've heard about that party happening on, you got the invite, you're inside of it. Okay? That closes, that's a solid line, that's a dash, sorry, that dash becomes a solid, that open becomes a close, you're in there. Okay. Okay. So let's go at it today. These are ones that the SAT tend to definitely like to ask, along with those just regular lines, all right, linear graphs, the linear inequalities. So this is a good one to talk about here. Let's go do it. Who cares if it's a linear inequality or if it's our parabolas or quadratics? We want to talk big ideas here. Go at it now. Take number 3, take a quick minute. I don't care what type of graph I give you. It can be any type of graph. What we want you to think about is, what does it mean to be in a shaded region? What's it mean to be a solid versus a dashed? Just take that away from it. Don't overthink it. I know it's math. It's got to be super complicated sometimes, right? Maybe, but not all the time. Take away that big idea. On that number 3 then, just run it through. Which of those is going to be a solution? Circle them out. And what do you got? Okay. So there's a parabola. We can do those with parabolas. Next year, you will do those with parabolas. Okay. But they're nothing crazy. We're going to do the exact same thing we did to start graphing those. And the only difference is, would they be solid or dashed? We're going to talk about how we graph those in just a moment, as I know some of you are already doing. And then, where do you shade them? And learning how to shade them is nothing crazy. Okay. All right, real quick, -2, 0, yes or no? -2, 4. Yeah, it's on there now, isn't it? And because that one is a what? It's solid this time. 0, 0. It's on there, but because it is solid. 4, 0. 4, 0 is over here, clearly in the shaded zone. -2, -10. No, it's straight down, isn't it? And that's going to continue opening out to the left and right. That's going to expand out that unshaded zone. So -2, -10, not going to happen, is it? And lastly, what about 4, 10? Yep. Okay. All right, let's roll. Number 4 is, I know some of you, because I hear some shading going on. Graph me the line. Graph that line like you've been doing for years. What's the y-intercept? What's the slope? Play that slope game. We've been reviewing lines this school year. The only difference is, before you just go immediately and take that ID, you got to think, is that ID going to make it a solid or a dashed line? That's the only thing you got to think about. Okay? So, y-intercept is 1, and what's my slope? Yep, -1 over 1. So that means what? Down 1, right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. I like a few extra points, and I always like to reverse those few extra points. Down 1, right 1 means up 1, left 1, up 1, left 1, up 1, left 1, and then I take my ID to do a what? Solid. It's a solid one. Why is it solid again, Kate?
Because it has a little line.
Has the equal to underneath of it. Thank you. So, boom, take your ID, as Caden said, make me that solid line. And then don't move on yet. It's an inequality. I should have a shaded region. Shaded region above or below that boundary line. I'm sorry? It's above, because what is the inequality symbol read as? It's a greater than. Don't overthink it, okay? Greater than, I think of above, I think of larger, and we got these two regions that we've created, and yeah, don't get lazy as you shade it. When I shade that myself, okay, I like to go and just kind of exaggerate that out, because all this continues on as we were just doing those solutions a few minutes ago. This just continues on forever and ever and ever, okay? But anything below that boundary line is not happening, is it? Okay. All right, let's take letter B. Real quick, let's go graph B. Y-intercept is. Slope is. Yep, and on that negative 1/5, just watch it out. Remember, we've talked about this before, we reviewed this before, and we did that same thing on the previous one. Only the one of those get the negative, and then we'll flip it out. But don't put both of them are negative, because two negatives will make that a positive. Right, make it a positive. Down 1, right 5. Reverse that, because I'm done. And then up 1 and left 5. Take that ID and make a what type of boundary line? There you go. Above or below, above or below? Above. So again, exaggerate it out. Don't get cheap, exaggerate it out. It doesn't need to be like super dark or anything like that, but just shade it in, but exaggerate it out. Doesn't need to be contained in that coordinate grid either, because I'm expanding it out past that coordinate grid. Continues on over and over. Okay. All right, let's do letter C. What's the problem with letter C? It's not in our slope intercept form, is it? Doesn't have y by itself. Let's play the rearrangement game. Okay, that's our algebra 1 skills coming into play, our solving skills coming into play. Make it look like A, make it look like B. What are you going to do first to rearrange that thing? What are we going to do first? Subtract that 4x, okay? So I'm going to bring it to the side because I'm not going to have the room there. Probably you guys aren't either. I'm just going to bring it off to the side then, okay? As I rearrange that now, you all said subtract 4x, absolutely. Okay. Now, put that in that slope intercept form, okay? As I do that, as you do that, our next step here is to do what? Got to have a y equals. Got to have a y greater than here in this case. Got to divide by -1. All right, nothing fancy going on with that one. We're just solving for a variable. Absolutely. Divide by -1, and then just watch your arithmetic skills as always. Okay, -4 divided by -1, and 4 divided by -1. Just remember back to your about 8th grade teachers. What do we gotta remember now?
Flip the inequality sign.
You gotta flip the inequality. When we're dividing by negative, that flips our inequality symbol. When you're changing the signs there, we do need to flip our inequality symbol. We only do that when we divide or multiply by negative. We're not changing the symbols, not changing our signs when we add or subtract, or we divide by a positive. When we divide by a negative, we're flipping those signs around. So we do need to do that right here from a from a greater than to a less than or equal to. That is the one thing I wanted to point out here, is that students will tend to forget that, hopefully not, but that's the one thing I wanted to point out here. Okay. Graphing the line is pretty straightforward, but that's the one thing I wanted us to remember. All right, let's finish it off now. What do we got? -4 and the slope is 4/1. Up 4, right 1. Up 4, right 1. Take your ID and solid or dashed? It is solid. And above or below? Above or below that? I'm sorry? Below. It's less than symbol, right? And what would happen if you did not flip it? I'm sorry? If you do not flip the inequality symbol, what would you be doing then? Yeah, you'd be shading the wrong area. You'd be shading above it. So you'd be getting the wrong solution set. So you got to make sure you're watching out for that. They're easy things to mess up on. That's the one time you got to watch out for that with inequalities. Otherwise, it's everything's exactly the same. All right, let's flip. Let's go. Let's do one more here. See if you guys some time today to work. Letter D is the same deal, but we don't have to flip on letter D. Okay. All right. Number 5. Let's go graph out A. On A right there, well, obviously we're missing X, aren't we? Let's go back to beginning, not beginning, but the middle of the school year. We graphed these before. We've graphed these when we brought in our transformations, our reflections. We did a lot of work with these. When we don't have the other variable, we got our special cases of lines. We got either vertical or horizontals, didn't we? So what do we have here? Vertical or horizontal line? I know that's what I'm asking. Y equals is a
Horizontal.
It's a horizontal. Okay.
50-50.
And let's see. Obviously. Okay. It's gonna be horizontal, and the reason why this one's gonna be a horizontal. Let's say this was saying y equals instead of the greater than symbol. Okay. We want all the y coordinates to be 0. Okay. We want all the y coordinates to be 0. Where are all the y coordinates 0 at? Right here. Aren't all these points something comma 0? 1 comma 0, 2 comma 0, 3 comma 0, 4 comma 0, -1 0, -2 0, -3 0, 0 0. That's where we're creating that horizontal line. So in this instance, then, when I say y is something 0 like this, equals 0 or greater than 0, whatever, it's going to create that horizontal boundary. So then you got to realize, is it a solid or a dashed? It is a solid. You just got to know, think back, is it horizontal or vertical? Okay, so y to a number, it's going to be horizontal. Now we're not really, now we're going to remember shade above or below that. Yep, it's greater than, so we're shading above there. Okay. Now the next one, we're missing the y variable, right? So that's our other special case, isn't it? In our other special case, it says x what? Less than -5. Who cares if it says less than -5 or equals -5? You got to, again, remember x, not the other variable. That's our vertical line. So that's saying, hey, where's all the points that has x is -5 at? X is -5, -5, 0, -5, 1, -5, 2, -5, 3, -5, -2, -5, -4. That's where we're getting a vertical boundary line. All these points right there that we just highlighted are creating x is -5, x is -5, x is -5. That's where it's giving you a vertical. Solid or dashed though. Dashed. Now this one is not so much above or below, because we're vertical. So you got to think then, x is left or right, or x is then going to be left or right. It's going to go to the less than. It's going to be the other left, isn't it? Okay, we're going to go less than -5. We're going to go less than left. So we want to shade everything this direction. Okay. Okay. Just a couple of those special cases that I wanted to come back around to with, those dang verticals and horizontals. We haven't done a ton of it lately, but that's That's why I wanted to come back around to those with you. The other two we just talked about a minute ago. That's not a problem. And then the last two here, let's go with number 7, and we'll call it. Number 7. So, with the word problem here, Jess sells corn dogs and what? Pretzels from a food truck. She sells corn dogs for $3 each, and pretzels for $1.50 each. She hopes to earn at least $216 at the farmer's market. Create a linear inequality in standard form. We'll talk about that here in a moment. That represents the solutions to the problem. X is going to be the number of what? Corn dogs she sells, and Y is the number of pretzels she sells. So, standard form. Standard form. We keep talking about slope-intercept form. That's our go-to one. It always will be. Standard form, we've seen it already here today. Standard form, we haven't done a lot of work with. We don't do a lot of work with that in geometry. It's more your Algebra 1 classes that you will, and Algebra 2 next year. When we talk about standard form, we've talked about standard form when we've done quadratic work. Ax squared plus bx plus c, right? When we're talking about standard form here, standard form is very similar to that. It's just ax plus by equals the c. Standard form has different meanings depending on what you're working on. Okay, I know math has got to be sometimes confusing because it's math class, right? But you got to realize, what are you talking about? Standard form depends on what you're talking about. Here we're talking about a linear work. So standard form means this little setup, which if you look above, think right above that, which is letter C, that's what we're trying to create. That's a standard form inequality, where you have x and y on the same side, set to something on the other side. And that usually is like a total. Okay? That's like a total that we want to get to. Well, that's what we're doing here. Okay, how we get into that total of what? 216. Just like if you're yourself is selling something. We're selling corn dogs and what? Pretzels, aren't we? So let's get to that. All right. $3 for however many corn dogs you sell, right? What is that $3 of corn dogs corresponding to? Yeah, it's corresponding to X, right? You don't know how many Jess is selling. Jess doesn't know that. We just know $3 times however many she sells. Is she selling anything else? Plus, how much on pretzels? About 50 times Y, right? Is she selling anything else? If she was, if she's selling bottles of water or lemonade or anything like that, we would put a plus 2Z, something like that. If she's selling something else, plus another variable. If she's selling, funnel cakes, plus another variable, 5A. That's how basic businesses are working. Okay. Now we're not. Well, we want to get it to a grand total of at least. There's that word of at least 216, which means it's not an equal sign. At least means I'm happy with 216, but what would I be happier with? More than that, right? So what inequality symbol goes with that? Yeah. Greater than or equal to. So here's how she's making her money, right? Okay. I'd be happy with 216, or just be greater than, just be happy with 216. But what would she be even happier with? More than $216. So when you say the word at least, I think a lot of times the word at least, I think of that least and think of less than. That's what a lot of students will associate with that with. But really, at least is associated with more than, right? Now, here's some combinations that's going to get her to that $216. Which of those combinations is going to get her to that? I said I lied to you earlier. I said you didn't need your calculators, but actually we kind of do here. So what is this combination here of that first one happening? 72, 0. What does that mean? She sold how many what? And sold how many what? Yeah, she sold 72 corn dogs, and it was a bad day for pretzels. She sold 0 pretzels. Okay, is she going to make that combo? So as our calculator, off that, okay, 3 times, what is it, 72? Plus $1.50 times 0, which we know is going to drop out. Is she going to meet her goal?
Yes.
Okay. Bad day for corn dogs. 3 times 6 plus $1.50 times, what is it? 132. Is she going to meet her goal? Okay. Bad day for corn dogs again. But okay day for pretzels. Is she going to meet her goal? Okay. On the next one, kind of split. 3 times what? 60 plus $1.50 times what? 42. She meet her goal. She surpassed it, didn't she? So, in those instances, those are all different combos there that can work for us or her to meet her goal. Now, these also meet that goal. 3 times 0.5 plus what? 143 times $1.50. She meets her goal, $216. Same with this one. 3 times 70. 3 times 72 plus $1.50 times -1. Whoops, that one did not. I must have typed in looks great something one. -1 does not for some reason. But the first one did. They are solutions, but they don't work in this situation. Why does that first one does not work in that situation? What's that? You can't sell half a corn dog. It worked, didn't it? That first one, I cleared it out already. That first one did work, but in context and situations, you can't sell half a corn dog. Just can't sell 0.5 corn dogs. What can you sell? You can only sell whole corn dogs, can't you? And on that last one, I need to bump it up a bit. But the other one, if I made it say 80 corn dogs and a -1, it would still work for the math, but does it work in the context of the situation? Obviously not. You can't sell negative pretzels. Okay, so here you got to think about what does it work in the context to the situation. Okay. All right. I think that does our linear inequalities.